Hello, thanks for joining us at Microsoft Build 2020. Today we're excited to talk about a new event-driven portable runtime for building microservices called Dapr, or the Distributed Application Runtime. Released last fall in partnership with the Azure Incubations team, Dapr is rapidly taking off in the open source community and generating lots of excitement. Today, Mark Fussell, Principal PM Manager for the Azure Incubations team, will walk us through what Dapr is and how you can use it to build your applications. Over to you, Mark.
Thanks, Aaron. Thanks for the intro. I'm super excited to be here at Build today and to talk to you about Distributed Application Runtime. So let's dive in and get started and find out what it does for you. What we find today is that developers are being asked to build these resilient, scalable, distributed applications, and they're hard, they're complicated. And as developers like yourself know, you often use the right tool for the right job. You often have to build these applications with multiple different types of languages, multiple different types of frameworks. And so these applications tend to be sort of polyglot in nature. And also, as a developer, you want to focus on building business value. You want to build applications, not infrastructure. So at the same time, though, that we find that there is things holding you back from development. I mean, typically we find that the number of tools and the actual runtimes that help you there are fairly limited in nature. We find that particular runtimes may only support particular types of languages, or say a runtime only does web applications, it may not have an event-driven mechanism around it all. And you are then left at the mercy of the runtime owners to add those features in, and you're constrained about how you can build these applications. Equally, we find that, the runtimes are tied to a particular hosting platform. They'll only run in the cloud, or they'll only run on the edge, or they'll only run on a particular type of hosting environment. And so the portability of your code, particularly in this multi-cloud world, becomes hard. So all of these challenges were what focused us to think about how we can solve these problems and make it easier for you as a developer's life. And that's what Dapr's goals are. At its core of Dapr is a set of best practice building blocks, real codified pieces of code that make you as a developer, a superpowered developer, to build these distributed apps. And you could do that with any language or any framework of your choice. Importantly, they have a set of consistent, open APIs, and wherever possible, we adopt standards, things like cloud events or open telemetry. And key as well is a pluggable, extensible component architecture. This means if you've chosen a particular state store like Redis to store your state, but then you need to swap it out and use Cosmos DB, or you've used a different eventing mechanism, you can plug in different components of your choice from multiple different clouds, whether that's Azure or AWS or the cloud of your choice. So all of this makes your code platform agnostic, capable of running on the cloud and the edge. And everything that happens about Dapr is driven by the community. Since we launched Dapr back in October of last year, over 140 different external contributors have contributed components into the runtime, and we're thrilled about the excitement that's been generated inside the community. So we describe Dapr then as this portable, event-driven runtime that makes it easy for you developers to build these large-scale, resilient, distributed applications that can run anywhere on cloud and edge. So let's dive in a little bit more and look at those building blocks. At its core, Dapr has these set of building blocks. For example, one that does service-to-service invocation. It'll figure out where to do a call from one service to another inside your hosting environment. And these building blocks are exposed over common HTTP and gRPC APIs. So that means you can access and run these building blocks from any application code of your choice. So you'll see here at the top how easy it is for me to call onto one of these building blocks as a developer. It's like a REST call. I can do a local host call, and in this particular case, I can decide to call the new order method here on the cart service that's running somewhere inside my environment. Dapr does all the hard work of finding the cart service, doing a secure communication to it, and dealing with things like failure and resiliency calls to the wherever that service is running. Or for example, say I wanted to save some state in a state store of my choice. I can retrieve state and key value pairs from a particular state store. And importantly, although we have HTTP and gRPC APIs, we also provide higher level abstractions for particular SDKs that make it more productive for you as a developer if you know you just want to stay as a Python developer or a Java developer or a .NET developer. So how does Dapr achieve all this? The key is it has a sidecar library architecture. So let's go and dive in on what that means. Here's an example of an application. It consists of two services, Service A and Service B, and each service is launched with its own Dapr sidecar. Now, Dapr here does all the heavy lifting. So when I want to call from Service A to Service B with that service invocation building block, Dapr does the secure communication channel and all the retries. Or say, for example, I want to send a publish and subscribe event between my two services. I can take advantage of the publish and subscribe building block of Dapr. Now you'll see here the key element is that the publish and subscribe building block can plug in RabbitMQ or NatServe or Service Bus or Redis and many others that have been contributed by the community. Or equally, I can have my code triggered from external systems, such as a tweet or a message from Event Hub, that gets sent into my application, my service here, Service A or my application of my choice. And then all the diagnostics, the tracing, the logs, the metrics are all captured for you by Dapr, which is a hard problem in itself to solve. And they're all pushed into the observability tools of your choice, be that Prometheus or App Insights or Jaeger or Zipkin. And this pluggability model helps you become very flexible and portable in your approach to building these large-scale applications. So let's dive in and look at the key management building block, and then we'll build an application together. So here's an example of what the building block for the key management for the state store will do for you. I can take advantage of saving some key value pairs. For example, I can save some information about a planet into a state store of my choice, and then I can see all the information that gets stored in my state store. But say, for example, I want to retrieve the data from that state store. I can simply do a get request on the local endpoint onto the name of my state store for the planet key and retrieve the data. So that's how simple it is just to call onto these local endpoint HTTP or gRPC to take advantage of these building blocks. So let's go and build an application. The application we're going to build uses a Twitter component. The Twitter component is configured for querying on particular tweets. Every time a tweet happens, it gets sent to my localhost tweets endpoint. And from there, my Twitter provider simply stores my state into my local state store. So let's go and see this in action, and let's roll the first demo. First, let me show you how easy it is to get started with Dapr. Dapr is a CLI that allows me to do local development. I can do Dapr init that configures Dapr on my local machine, including setting up a local Redis state store. I can do Dapr run that runs my application with Dapr as a sidecar. I can do Dapr list that launches and runs and shows all the running instances of Dapr on my machine. We're going to build this application in both .NET and in Node. So let's look at the .NET version of this first. Underneath my .NET application, I have a components folder here. And you'll see that in the components folder, I have a Twitter and a state store component. Now the Twitter component configures a Twitter binding here, so that every time I get a tweet on a particular query, the tweet will come at this particular endpoint. The state store here is configured up to use my local Redis state store here. So the state store is called Tweet Store, where I'm going to save all my tweets to. Let's look at the code for .NET, which is written in ASP.NET Core. Here I've taken advantage of using the Dapr first-class client for .NET in order to build my application. And using this client, I can save everything inside the Tweet Store. How do I do this? Well, first, I'm going to configure an endpoint here called Tweets, which is where all the tweets that come in from my Dapr component are sent to. And this is the tweets endpoint just inside here. You see inside the tweets endpoint here, I receive the request. I take the body of the stream, I deserialize it into a Twitter class, which I then use the Dapr client to with its save state async method in order to save that into my state store with a particular tweet ID and all the tweet information about it all. So this line here shows how incredibly easy it is for me to receive the Twitter information and save it to my local state store. So let's go ahead and run this application. I'm going to take advantage of the Dapr CLI. So here I'm going to do Dapr run, the name of the application, which I'm going to call provider, the port it runs on. I'm going to launch Dapr on port 3500 as well using .NET Run. So when this starts up and runs, you'll see that as new tweets are posted, each one of those will be sent and displayed in the console window here. So here are the tweets coming in. This is a query about cats. Clearly the internet has plenty to say about cats. So if I just stop this here and go and look at the Redis Explorer, and let's expand and refresh the Redis Explorer here, you'll see inside here, I will have each one of these tweets that I sent with its particular ID saved. So this is the name of the provider and this is its ID, and here's all the tweet information saved inside the Redis state store inside here. Super simple to save it all away, and I can save as much data as I need inside this particular line item inside this entry. Let's now go and look at the Node version of this application. So again, with the Node version of this, I have a components folder set up for state store and for Twitter. This time though, the application is written in Express, and this is a very simple Express application. So I haven't decided to use the node library. Instead, I'm just doing direct HTTP calls. So you see here, I'm doing a local host call with the Dapr port, the 3500 we're using in the CLI. And then I'm simply going to call on to the state building block and say, save everything to my tweet store, which is the same as the Redis state store we're going to save all our data to. As before, I have a tweets endpoint here, which I get called onto. I take the body of the request that comes in, I turn it into an object here with all the necessary Twitter information, and then I call the save content endpoint. If I look at the save content endpoint, you see it's as simple as doing a post message with the content to this state endpoint here in order to save my data. So this shows me how you can build a application using Dapr, using the Dapr building blocks for state and for the bindings, and how quickly I can get started. So let's dive in now and look at a couple of other building block capabilities that Dapr provides you. In a distributed systems world, it's extremely common to build event-driven systems. And so publish and subscribe concepts are paramount of importance. So for example, say I was building an application where I wanted to send a message from my cart to two other services, in this case, a shipping service and an email service. Both those services can subscribe to a particular message, a particular topic, in this case, the order topic. And now my cart service can simply publish that order topic, and Dapr will do all the hard work of delivering the messages, the topics, into either the shipping service or the email service. And once again, the pluggable concept of being able to plug in a pub sub provider, whether that's a Redis state store or NAT server or Azure Service Bus between the two, is key. So this publish building block allows me to build these high-scale distributed systems where I can publish messages and subscribe to topics between my services running in whatever environment I've chosen. Or equally, I can decide to do a direct call between one service and another, an RPC-like call. So in this case, I'm going to call from the front-end service to the cart service. Dapr will take care of doing the secure communication, take care of retries, and take care of failures. And in this case, I'm going to call the checkout method on the cart service, wherever that's running inside my system. So as a developer, I can simply call the invoke building block and call the checkout method. Dapr does all the hard work of finding and discovering and calling that particular service inside my environment. So let's take those building blocks. Let's go back to our Twitter application and let's extend it a little bit further. We're going to do two things. First, we're going to add a second service called the Sentiment Processor service. Now, this service calls out onto Azure Cognitive Services, and I called it directly from my Twitter provider service using the Dapr building block, and I call onto the Sentiment Score service on the Sentiment Processor. And what this does is it'll take the message that gets called to me, it'll call up to Azure Cognitive Services, it'll score my tweet for positive, negative, or neutral sentiment, and then hand back the result to my Twitter provider. The Twitter provider then will do a publish message. It will publish a processed tweet topic message onto another service that's running, in this case, the tweet viewer. And the tweet viewer will simply receive those processed topics and then show them up on a website for a UI. Now, the key here is that I've also built the Twitter viewer in a completely different application. I built this inside Go. So I've got 3 different types of services here, all built in different types of languages. And in this case, I'm running this all locally. I've used Redis as my state store to save my tweets still, and I'm using Redis in order to send my processed tweets. So let's go ahead now and roll a second demo and see how this gets built out. So let's now extend this application and add 2 more new services. We're going to add a processor service here, which is written in Node and does a sentiment analysis on a tweet. And we have another service here, which is written in Go, which is a viewer service that displays the results in a UI. If we go look at the provider service here and open up its app.js, you'll see that we've added a publish content service and a score sentiment service. So just as before, we've received tweets on the tweets endpoint from the Twitter component in our components folder. But this time, for each tweet, we're going to call the sentiment analysis service, then save its content, and then publish it to the UI using a published content. So how do we do that? Very straightforward. We take advantage of the building blocks of Dapr. So here we can call onto the service endpoint, we can call the invoke method for the sentiment score method on the processor service here. So equally, we can take advantage of, as we did before, saving state into our tweet store, and also we can take advantage of the publish building block in order to send a processed tweet. If we look at the sentiment score service, just like before, this is as simple as calling a post message onto an endpoint, which is set up on the process service. So let's go and look at that method. If we open up the processor service and we open up its app.js, you'll see here's the sentiment score service that we can call. So this is doing direct service-to-service invocation using Dapr. Dapr is doing all the hard work of calling from the provider service to the processor service for you onto the sentiment score method. And the sentiment score method here takes advantage of Azure Cognitive Services. Equally, if I go back to the provider here, you'll see that after I've called a sentiment service here, I'm now going to call on publish to content. And the publish to content method here, just as before, does a post message here, but this post this time is posting a pub subtopic, taking advantage of Redis as a state store using the publish building block of Dapr. Well, how does it do that? Inside the provider here, there's a component here for a pub sub Redis state store called processed. And equally inside our viewer service inside here, if I open up the viewer service inside its components folder here, it too has a pub sub component which is identical and receives messages for the processed tweets on its UI. So let's go and run this application. I actually already have two of the services up and running already. I have the viewer service and I have the processor service up and running here. So I'm just going to simply launch the provider service here. Now this time I'm running it in Node, so I'm doing Dapr run node app.js with the name of the application. So when I run this, it'll start up, it'll start receiving tweets. The provider application hooks together, calling first onto the sentiment analysis processor service. And when that gets back, it then sends the results through a processed topic. So here's all the tweets coming in. You'll see here, if I actually go and look at the processor service, these are them being scored with their sentiment analysis inside here. So I'm just going to stop the provider here a moment. Just as before, if I refresh the Redis state store, you'll see here all the tweets that are being saved, just like we saw in our earlier application. But also you'll see here that I'm taking advantage of Redis as a pub sub provider. So I'm sending all of the processed topics between the provider into the viewer service. And as a result of all of this, if I switch over to my viewer service here, which is running locally, you'll see all of the tweets here that are displayed in my UI with their sentiment analysis, whether they're negative, positive, or neutral. So this shows how straightforward it is for me to build out an application, how I can take advantage of the building blocks now using simple HTTP calls, either for doing direct method invocation on another service, saving state, or using the publish building block in order to send a topic between two services.
Great, so everything that we built so far, I've built on my local machine, and I've taken advantage of Dapr's capabilities. It's easy to use capabilities of local development. And on my local machine, I took advantage of Redis for both publishing the tweets between my services and also saving my state. But the key to Dapr is that it's not tied to any particular platform or any hosting environment. So I can take all the code that we've built here and I can host it and run it in another hosting environment, for example, such as Kubernetes or IoT Edge or Service Fabric or any other hosting environments that you can run a distributed app in, or just an application actually for that matter. So Dapr is not tied to any particular hosting platform, which is a key to make its code portable. What's more, if I publish this into a cloud provider environment, I can swap out through the component model. Instead of using Redis for the state store and for the publish and subscribe mechanism, I can choose to use something like Azure Table Storage to save my tweets into, or I could take advantage of Azure Service Bus in order to do the pub sub mechanism. So this now, I could take this whole application and I can move it to a completely different public cloud, and I could swap out for a different component and use, say, GCP pub sub for the processed for the publish and subscribe messages, or Google or Firestore for saving of the tweets, and that makes my code entirely portable. If you want to see an example of how I've taken the same application just now, if you go to aks.ms/dapr-build 2020, you'll see that these demos have been posted onto our YouTube channel, and you'll be able to watch a video there of how this same application has been deployed onto a Kubernetes cluster and how there were no code changes in order to make that run.
So with that, I would love you to talk to you about how you can join our community. We have a vibrant community. Come and visit github.com/Dapr. That's where all the source is open repoed. There's a fantastic getting started guide there that walks you through all the different building blocks. It does it in a number of different languages, so you can get up and running to understand how I can build Dapr both locally and inside hosting environments like Kubernetes. Every 2 weeks, we have a community call. If you go to aka.ms/Dapr community, that links to how you can join both the Gitter channel, where you can ask questions at any time of the day, as well as come out onto our community calls that we hold every 2 weeks. In fact, we'll be holding one next Tuesday for the one inside May. And of course, subscribe to our Twitter channel at DapperDev, because we love to hear about what you build and what you do with Dapr. So with that, Aaron, let's try and take some questions.
Alrighty, now the comment section has been blowing up, so we have a long list, so hopefully get through as many as possible.
Okay.
First up, let's say you're developing a .NET Core or Win32 application, and you want to plug into Dapr. Can you do that without using Azure or any cloud platform?
Oh, entirely, yes, yeah. So Dapr is entirely cloud agnostic or even platform agnostic. So, I can just run it on my local machine, or I can run it on a set of VMs, or I can run it on low-powered devices. I mean, Dapr will compile down to ARM devices, so you can run it on a Raspberry Pi if you want to, if you want a small compute device like that, as well as sort of Win32, as well as Windows and Linux operating systems. So yes, it's not bound to any particular platform, and that's its key goal in order to make it portable.
Perfect. All right, so let's say you're a developer writing an application. How does Dapr compare to Service Fabric, and how do you decide what to use where?
Well, Service Fabric is a hosting platform as well as a layered stack that had some programming model concepts at the top of it all. So it went from providing clustering technology to resilience and failover, as well as a set of actor and reliable services programming models. The key for Dapr is it focuses on that programming model layer. In fact, we took all of the learnings, for example, from the active programming model from Service Fabric and moved that over into Dapr. So you have a rich actor capabilities in multi different types of languages. So Dapr will actually run on sort of Service Fabric environments, but Dapr will also run on Kubernetes. You could also make it run on Docker Swarm and Mesosphere, and so that's the key. It's the portability and the lack of being tied to a particular platform. Whereas Service Fabric was an integrated stack of technologies that were powerful, but you had to consume it as a whole.
Awesome. All right, here's a question for you. So are auth-z policies out of scope for something like Dapr, or do you plan to leverage something like Open Policy Agent in their sidecar for standardization policies?
Oh, wow, that's a great question. Actually, we've had some good discussions happen in the community recently. In fact, at our last community call, this very topic was brought up about how could Open Policy Agent be used. And because we are looking at how we can make a portable framework across lots of different cloud providers, it's a very attractive mechanism. So yes, we haven't done anything about it just yet. But given the interest and the questioning about this that we've had at our community calls, I kind of think that it's an inevitable direction that we will take to provide auth-z policies that you can plug in. Fortunately, Dapr has this concept of a middleware components. You can have this sort of middleware pipeline that it does processing. And we do sort of auth-z authorization today with that middleware component. And so it would be relatively straightforward to take Open Policy Agent and build out that middleware and run it inside there. So yeah, great question. I'd love to see that happen. Yes, please come and help us with that.
Perfect. All right, next up, is there a notion of service discovery in Dapr, or do services have to know each other's URL?
No, Dapr does service discovery, although, let's be clear, what it takes care of is it uses the underlying host platform. So for example, when you run Dapr on your local machine, it does local broadcast across those local machines, or actually even across a set of machines, in terms of that's built into the Dapr runtime. But when it gets deployed into Kubernetes through the pluggable component model, it takes care of Kubernetes DNS resolution inside there. So, but at the same time, Dapr provides capabilities on top of just the resolution mechanism the platform provides, because it also provides security between those calls, and it does failure and retries. So you get all of this value add on top of just a service discovery. So that combination of the platform service discovery with Dapr doing things like security and resilience gives you the power of being able to call any service inside your hosted environment.
Cool. All right, here's another one for you. Does Dapr work with reverse proxy servers like Nginx or Traefik?
Oh, yes. In fact, very much so. I mean, in fact, we talk about Dapperizing as a verb, those reverse proxies. So, for example, one demo we've shown is we've taken Nginx, and when we launch Nginx, we launch Dapr as a sidecar next to it all. Now, when the ingress comes into Nginx itself, Nginx, by configuring its routes, can send the request into Dapr as its sidecar, and then from that point onwards, your communication, beyond the reverse proxy to the other services inside your environment will be done securely and with tracing and diagnostics and all of the capabilities that Dapr provides. So yes, Dapperizing Traefik or Nginx or any one of these reverse proxies is a key scenario.
Awesome. And then on the topic of Dapr integrating with other services, how does it fit into the concept of service meshes? Is Dapr a service mesh? And how does it fit in with the others like Istio or Envoy?
Well, there's definitely an overlap here for certain. I mean, when you look at the service invocation building block, it's all about calling from one service to another and invoking a remote method on that service. And service meshes provide the same sort of things. In fact, service meshes provide policy-based routing, invocation, and observability characteristics. Well, two of those three, I guess, Dapr provides. It provides rich diagnostics, and it also provides sort of the service invocation. It doesn't do anything today around policy-based routing. But saying that, the goal of Dapr is that it will integrate very well with all of these reverse proxies. So in fact, we did if you go to our YouTube channel at our, that link I pointed to you earlier, there's a great video there that we show how Linkerd and Dapr run side by side, where I just chosen to use Linkerd for all of my network routing instead. So that, you just chose that I'm not going to use the service invocation. I just want to use the other capabilities of Dapr, like state management. And so Dapr plays very nice with all these with all of these service meshes.
Fantastic. Look, it seems like Dapr can integrate with a lot of different services, both first party to Microsoft and third party. In doing so, on the topic of security, how does it handle secrets and how can you develop your applications with Dapr securely?
Yeah, so one thing I didn't actually touch on in this fairly short intro to Dapr was that there's a whole building block that we have called the secrets building block. And the secrets building block, what we found is that so many developers have to struggle with, like, I just want to get hold of the credentials for talking to the SQL Server database or this external resource. And then they have to bring in, a set of libraries like Azure Key Vault libraries and integrate them with their app. And then they have to do all of the right authentication against them all. So one of the building blocks that you saw was a secrets building block. For you as a developer now, all you simply do is a local host call to get hold of the secret. And then you can plug in HashiCorp or Key Vault or any other one of the store providers, and Dapr will do all the heavy lifting of talking and authenticating to the key store, bringing back the results and allowing you just to get hold of the secrets within inside your app. And in the case of Azure, it'll all do that in the scope of also taking advantage of managed identity. So we've seen many people who just have to, going back to that distributed application, they just wanted to get hold of secrets. And so the secrets building block makes it incredibly easy for you as a developer to manage secrets in your application.
Perfect. All right. And with our last minute and a half, what the popular question is, when can we expect a version 1.0 to be ready for production workloads?
All right. Yes, this is a very well asked question. Well, Dapr's been out 6 months. It's been an explosion from the community, and we actually have quite a lot of production customers who are building applications against these. But our goal is for those production customers to kind of get into production. So once they have kind of got those apps running, and we've done perf and scale and security and all the other hardening tests on Dapr, we're certainly looking at getting a stable release out this year. Hopefully it's sooner this year, and I'd like to think it's kind of mid to kind of the second half of this year. That's our goal, but it all depends on those customers coming back, giving us the confidence that Dapr is ready to go into production.
Perfect. All right. And then for all the questions we weren't able to get to, definitely please come join us on our next community call. And yes, you can ask all the questions that we weren't able to get to today. And with that, I'll kick it back to Mark for the final remarks.
Yes, in fact, the community calls are so important for us. We hold them, in fact, next Tuesday we'll be having one. We'd love you to come along. That's a chance for you to see great demos that we hold. We always kind of talk to you about the roadmap. We're very open and transparent. You can ask any question you want there. And we're thrilled to have you come and join our community. Please star and like the GitHub at Dapr, and we'd love to see what you build with Dapr. Thank you.